Good day everyone, you're welcome to Mastery Lectures. So today we are going to be looking at empirical and molecular formula calculations. Calculations on empirical and molecular formula. Now, what is empirical formula? Empirical formula can be simply defined as the simplest formula of a compound that just shows the ratio of atoms in the compound. For example, if we take this molecular formula of glucose, C6H12O6, this is the molecular formula of glucose. Now, the empirical formula of this is CH2O. So, empirical formula is the simplest formula of a compound that shows the ratio of atoms present in the compound. So, the ratio of carbon, hydrogen, and oxygen present in glucose, C6H12O6, we have it as 1:2:1. So this is what you call what? Your empirical formula. Now what is this? This is your molecular formula. Now what is the molecular formula? The molecular formula is the formula that shows the actual, the actual formula of a compound, showing the exact number of atoms present in the compound. So if you look at this guy, glucose, so there are 6 carbon, 12 hydrogen, and 6 oxygen. So that's the molecular formula. So the molecular formula gives us the actual formula of the compound, while the empirical formula only shows us the ratio of atoms, present in the compound. Now, look at this question. It says a hydrocarbon contains 92.3% carbon by mass. What is the empirical formula of the compound? Now, what is a hydrocarbon? Please take note. A hydrocarbon, pay attention, a hydrocarbon is a compound that contains what? Carbon and hydrogen. So any compound that contains carbon and hydrogen, they are called what? Hydrocarbons. Carbon and hydrogen alone, alright? They are called hydrocarbons. So now, we asked to find what? The empirical formula. Now, to look for empirical formula, there are 3 rules you must know, alright? Number 1, or majorly 2 things you need to do. Number 1, you are going to divide by the molar mass of the atoms, and then you do what? Divide through by the smallest number. Okay, then thirdly, one secret I always tell students. Now this secret you cannot find it in any textbooks, all right? It is a secret we came about with after solving a lot of questions. We were able to come about some secrets on empirical formula that will help you in calculations. Now, one of those secrets is the fact that from 3 to 7 do not approximate. From 3 to 7 do not approximate. So if you can keep these 3 things in mind, then we are good to go for empirical formula. So now let's come back. A hydrocarbon contains 92.3% carbon by mass. What is the empirical formula? So remember I told you that hydrocarbon is what? Hydrocarbon is equal to what? Carbon and hydrogen. So hydrocarbon is carbon and hydrogen. Now we were given the percentage of carbon. So the percentage of carbon was 92.3%. But now we were not given the percentage of hydrogen in the hydrocarbon. But we can get the percentage of hydrogen. So how do we know? For hydrogen, now to get the percentage of hydrogen, we'll say 100 minus 92.3. Why am I using 100? Simply because the compound, the mass of the atoms present in the compound in percentage, and percentage means 100. So if you say carbon contains 92.3%, so it means out of 100, 92.3 is carbon. So when you just subtract 92.3 from 100, whatever is remaining will be our hydrogen. So when you put that into your calculator now, when you do that, what do you get? You're going to get 7.7. That's what we are going to have. 7.7. Let's see. So 100 minus 92.3. Okay, good. 7.7%. 7.7%. So now we are good to go. 7.7%. So we know our percentage of carbon and hydrogen. So I will draw a table like this, or better still, you can just do it like this. Now one side you write carbon and other side you write hydrogen. So the percentage of carbon 92.3. That of hydrogen is what? 7.7. So first thing first, you divide by their molecular masses. Alright? What is the molecular mass for carbon? 12. So say divide by 12. What's the molecular mass for hydrogen? 1. So divide by 1. Or the molar mass. Okay? So 92.3 divided by 12. 92.3 divided by 12. You're going to have 7.69. Then this divided by 1, you have 7.7. 7.69 is similar to 7.7. So if you approximate, you get 7.7. But nevertheless, you can decide to say, okay, we don't want to approximate. Divide both sides by 7.69. Divide both sides by 7.69. So therefore, we have what? Carbon. What will be for carbon? So 7.69 divided by 7.69 is 1. Alright? 7.7 divided by 7.69. You also got 1.00, which same thing as 1. So carbon is 1, hydrogen is 1. Therefore, the empirical formula of the compound becomes what? CH. This becomes our answer. So the empirical formula for the compound is what? CH. So that is, we are done with question 1. That is the empirical formula of the compound. Now question 2. Question 2 now. Alright, question 2. What is the empirical formula of an oxide? Now, what is an oxide? What is an oxide? An oxide is oxygen plus elements. Oxygen plus elements. So it can be any element. The element can be a metal or a non-metal. Alright? So an oxide, so that means you are expecting oxygen in the compound and expecting what? An element. So if you look at the compound, what they give you, you say an oxide containing 72% manganese. So the oxide here is referring to oxygen and what? Manganese, or you say manganese. Alright? So now, what is the empirical formula? So we have the percentage of manganese to be what? 72%. When we give you the percentage of oxygen, no. So but we can get the percentage of oxygen. How do we do that? 100, similar to what we did in question 1. So 100 minus 72. Okay, so if we do that, 100 minus 72, what do we get? We get 28. So therefore, the percentage of oxygen is what? 28. Percentage of oxygen in the oxide is 28. Now let us find the empirical formula. Okay. So empirical formula of the oxide, so Mn and oxygen. Mn is 72, oxygen is what? 28. Alright, first thing first, divide by the molecular mass or the molar mass. What's the molar mass of manganese? We're given 55. So divide 72 by 55. What's the molar mass of oxygen? We're given 16. So 16. Alright, now 72 divided 55, what do we get? 1.30. Okay, let's just leave it as 1.30 to decimal place. Then 28 divided by 16, what do we have? 1.75. Now, after doing this, what do you do next? You divide through by the smallest value. Alright, between 1.30 and 1.17, which one is 1.75? Which one is smaller? Of course, 1.30. So we divide both sides by 1.30. 1.30. So you divide it by 1.30. So 1.30 divided by 1.30, you get 1. But 1.75 divided by 1.30. So what we got is 1.3. So that means MN is 1. Then our O is 1.3. Now, at this point, it will be wrong, very wrong for a student to just say he or she wants to just, don't want to use this 3, just want to approximate. So forget about the 3 and go and say, therefore, this one is just 1. So the other side becomes MNO. Now, this is wrong. It's very wrong. So it does not suit. Now, remember, this is where my number 3 secrets about how to find the empirical formula comes into play. I told you from 3 to 7, do not approximate. What do I mean? When you have a decimal number, alright, if the number after the first number after the decimal point ranges from 3, like this one starts from 3, after the first decimal point, it begins from 3. So if the first number after the decimal point begins from 3 to 7, it ranges from 3 to 7. Alright? Let's say you have 1.3, 1.4, 1.5, 1.6, 1.7. So from 3 to 7, please do not approximate. You don't approximate. What do you do to remove the points? You just multiply by a number. Look for a number that when you multiply through, alright, you will get either a whole number or you get a number with decimal point in which the first number after the decimal point is either 0 to 2 or 8 to 9. So that means you might have something as 1.0 or 1.2, alright, or 1.1 or 1.8 or 1.9. But if it's around something 0.3 to something 0.7, please do not approximate. Just multiply through by what now? A coefficient, a number. Alright, so in this case, we cannot just approximate this. So we have to multiply by a number, so a coefficient. So we're going to start with 2. So let's say we want to multiply through by 2. So MN1 O 1.3. We are multiplying by 2. Let's see what we get. So 1 times 2 is 2. So we have MN2 O 1.3 times 2. That is 2.6. Now we still cannot approximate. You can see it because the first number after the decimal point is 6. And I told you from 3 to 6. Do not what approximate. So we'll now try to use 3 to see if 3 will work. If we can times. So 3 times 1 is 3. Then 1.3 times 3. What do we get? 3.9. Can we approximate? Yes. I told you if the number after the decimal point is around 0, 1, and 2 or 8 to 9. Alright, then you can approximate. So this one is 9. So we can just approximate this guy. So 9 here, turn it to 0, add 1 here. Then our final answer becomes what? MN3O4. That becomes our answer for the compound. So the empirical formula of the compound is MN3O4. That is our empirical formula. Alright, so we are done with this. So this first guy, we got our answer is CH. The second guy, our answer is MN3O4. Now let's go for number 3. Let's try to solve number 3. So you can just, maybe before I clean the board, you can pause the video to write down anything you want to write down and then play. So we'll continue. Alright, for question 3, what is the molecular formula of an organic compound? Now this is not an hydrocarbon, okay? They said organic compound, so it is clearly stated that it is an organic compound, not a hydrocarbon. So containing 40% carbon, what is the molecular formula? So we are told to look for molecular formula percentage of carbon is what? 40%. 40%. Percentage of hydrogen is 6.6%. Then the percentage of oxygen, and the rest is oxygen. So they said the rest is oxygen. So they did not give us the exact percentage of oxygen. They only said the rest is oxygen. So what do we do? Here is where we apply wisdom. Okay, this is where we apply wisdom. You're going to add 40 to 6.6. When you add these two together, subtract it from 100, then you get the rest for oxygen. So now let's do that. 40 plus 6.6, we got 46.6. So it now becomes 100 minus 46.6. What do we have? 100 minus 46.6. We have what? 53.4%. So these are percentage for oxygen. Then they now said if its molecular mass is what? 180 degree. So the molecular mass, or the molar mass of the compound, is equal to 180, not 180 degrees, sorry, 180 gram per mole. 180 gram per mole. So we're giving our normal molecular masses. So first thing first, we're going to look for molecular formula. Now let's first calculate the empirical formula. We're going to find our empirical formula first. So we have carbon, hydrogen, and oxygen. They are the ones present. Percentage of carbon is 40, hydrogen is what? 6.6, oxygen is 53.4. Now what is the molar mass for carbon? 12. So we're going to divide through. The first thing, we're going to divide through by their what? Molar masses. So hydrogen is 1, divided by 1, oxygen is 16. So we're dividing both sides by what? 16. Look at it, oxygen is 16, hydrogen is 1, carbon is what? 12. So 40 divided by 12, 40 divided by 12, what do we get? 3.33. Then 6.6 divided by 1 is 6.6. Then 53.4 divided by 16, we also got 3.33. Alright, now at this point, what are we going to do? We're going to divide through by what? The smallest value. What's the smallest value here? We have 3.33 and 3.33. So we're going to divide everything by 3.33. So divide both sides 3.33, divide this side by 3.33, and divide this side by 3.33. So this divide this, you get 1. 6.6 divide 3.33. We got what? 1.98, or let me just say 1.9. Then this divided by this, got to 1. Now remember I told you, when the number after the decimal point, the first number after the decimal point, if it's 0, we can approximate, we just say it is 1. If it's 1, we can still call it this one. If it's 2, we can still say 1. So 1.2, same thing as 1. But if it's 1.3, now we have to multiply by what? A coefficient. Alright, a number. We just multiply it by a number. So, but here is 1.9. And I also told that when if it's 9, 8 and 9, right, maybe 1.8 or 1.9, then you can approximate. So we can easily approximate this guy because it's 8, 9. We just approximate it and turn it. Here is 9. So because it's 9, convert it to 0, turn it to 0, add 1 here. So therefore, approximately, our answer becomes 1, 2, 1. So the empirical formula is equal to what? C1H2O1. Or you can basically write it as what? CH2O. Good. Now, let us find molecular formula. How do we find molecular formula? The formula to get molecular formula, we have molecular formula is equal to empirical formula N. Now, what is N? N is molecular mass over empirical formula mass. Molecular mass over empirical formula mass. Please take note of this. Take note of the both of them. Very important. So now let's find our N first so that we can use it for the empirical formula. So what is N? N is equal to what our molecular mass? Molecular mass 180 over our empirical formula mass. Remember, our empirical formula is what? CH2O. So we have 180 is equal to, what is carbon? 12. So we have 12 plus, hydrogen is what? 1. But there's 2 attached to it. So now say 1 times 2 plus oxygen is what? 16. So N is equal to 180 over 12. 1 times 2 is 2. 12 plus 2, 14. 14 plus 16, I think that should be 30. 14 plus 16, yes, that is 30. So 180 divided by 30, what do we have? 180 divided by 30, we have what? 6. So now our N is 6. So since our N is 6, therefore our molecular formula is equal to what? Empirical formula N. Remember, what's now our N now? Our N now is now what? 6. 6. So what's our molecular formula? Remember, empirical formula is what? CH2O6. So 6 times 1 carbon is equal to what? C6H. 6 times 2, 12. 6 times 1 oxygen, O6. So that becomes what? Our molecular formula. This becomes our molecular formula. That's the answer. So it's very easy. Then lastly, we look at number 4. We're going to look at number 4. So please take note of these formulas. Alright, we're going to look at number 4. So number 3 answer, we got what? Our answer for number 3 is C6H12O6. Now here's an hint, here's a shortcut. Anytime they give you any question, they tell you find the molecular formula. You're given a question, they tell you find the molecular formula, and you just discover that the molecular mass is 180 gram per mole. 180 gram per mole. Once you just discover that, please don't solve. Just go straight to the option. Go and look for C6H12O6. That's the answer. Anytime they give you something like this and they give you molecular mass is 180 gram per mole, you are saying molecular mass, they tell you calculate molecular formula and they tell you the molecular mass is 180 gram per mole. Please don't solve. Just go to the option. Go and look for C6H12O6. You see there. And lastly, for question number 4, a hydrocarbon consists of 92.3% by mass of carbon. So this hydrocarbon, we are back to hydrocarbon again. What's hydrocarbon? Hydrocarbon is what? Hydrocarbon is equal to what? Carbon plus hydrogen. Carbon plus hydrogen. Alright, now what is our percentage of carbon? Carbon is 92.3%. Then finish. They did not give us percentage of hydrogen. We can get percentage of hydrogen 100 minus what? 92.3. So what do we get when we do that? When we did it before, I think we got 7.7. 100 minus 92.3. Yes, we got 7.7. So hydrogen is 7.7%. Alright. Then we're giving vapor density is 39. It's vapor density. So vapor density is equal to what? 39. What did they ask us to find? Determine its molecular formula. So what is the molecular formula? That is it. Now quickly, let's find the empirical formula. You know we have solved this before. So if you just go back to question 1, you know that, look at it, it's very similar. 92.3% carbon by mass. Alright? So already our empirical formula is what? CH. So already now our empirical formula is equal to, because it's the same thing, CH. So our empirical formula is what? CH. Now let us calculate the molecular formula. Now remember, to calculate molecular formula is equal to what? Empirical formula N. Now what is N? N is equal to molecular mass over what? Empirical formula mass. Now what is our molecular mass? We did not know. Alright, they didn't give us directly on the question of molecular mass, but they gave us something. Please, I want you to take note of this. Take note of this formula. Take note. This is a Riemann formula. Alright? It is a Riemann formula. Okay? Now take note. Molecular mass is equal to 2 times vapor density. Molecular mass is equal to what? 2 times vapor density. So therefore our molecular mass is equal to 2 times, what's our vapor density? 39. So 2 times 39, so molecular mass will now be what? 2 times 39. 2 times 39, that will now give us what? 2 times 39 will give us what? 78. So our molecular mass is what? 78. Alright, so molecular mass 78 over empirical formula mass. Remember, our empirical formula is what? C and H. So we have carbon 12 plus hydrogen 1. So when we add up, we have 78 all over what? 12 plus 1, 13. So 78 divided by 13, what do we have? We have 6. So therefore, remember, our molecular formula, remember this, don't forget this. Our molecular formula is now equal to what? Empirical formula N. So what's our empirical formula? CH. We solved it before in question 1. So CH, close bracket, then what's our N? 6. Therefore, molecular formula is equal to what? 6 times 1 carbon is what? C6. 6 times 1 H, that's what? H6. So our molecular formula is C6H6. This is known as benzene. This is the molecular formula for benzene. So thank you very much for watching. Please, I will advise you, go over this thing again, watch this video again and again and again until you grab the concepts. Alright, so thank you, and I'll see you in the next lesson. God bless you.